Oh, time for us to discuss weather on Mars. Some of the rovers have been equipped to make measurements of weather conditions, and uh, showing here 2012, the Curiosity rover, where it landed. Sol 10, this means the 10th Mars day that was when the measurements were recorded. Instead of just saying days, well, that means 24 hours to most people. They use the word sols, and the length of time for the sun come back to the meridian on Mars, so about 24 and a half hours time periods. But temperature, minus 11 degrees Celsius to minus 71 degrees Celsius. So this minus 11 degrees Celsius, if I try to do a quick conversion of this to Fahrenheit, you'd multiply by 9/5. So 9/5 minus 2 minus 18, and then add 32 degrees to get to the Fahrenheit number. So we're talking about 18 degrees Fahrenheit is as a temperature. That doesn't sound quite right, but I'm just doing that in my head. Minus 11 times 9/5 would be roughly minus 18, and adding the 32 would be about 14 degrees. So cold, and below the freezing point of water. 0 degrees is the freezing point of water. And taking a look at the pressure, 8 in the Pascal system here, and the pressure on the Earth is about 100,000. No, we're in pascals, so it's a little bit below 1% of the Earth's pressure, I believe. Humidity of 8%, pretty dry, and winds at 25 meters per second. So that's roughly 45 miles an hour. Curiosity rover has the ability to measure temperature, both the air temperature and the ground where the rover is located. So you can see the air temperature, and here they've thankfully put some Fahrenheit numbers so we can get a little bit more feel for things. So minus 103, minus 131.8, and warm day, 37 degrees Fahrenheit, got above the freezing point of water. Is this day or night? And down here, is this day or night? Now, day, when we have sunlight, we get the high temperature. So going from 37 degrees Fahrenheit down to minus 103 degrees Fahrenheit for this particular curve, and minus 132 here. So that's roughly a swing of 150 degrees Fahrenheit. Here in October 2014, we got pretty seasonable weather in Nebraska, around 70 and 50 at night. That's only a swing of 20 degrees Fahrenheit. Why is there so much temperature swing on Mars? Why does it change much more than on the Earth? And you should be saying thin atmosphere. It doesn't have the blanket that we do. So some of the general observations, the Wikipedia and Goddard Space Flight Center sites can tell us that sort of an average temperature is about minus 80 degrees Fahrenheit for the mean, and the maximum temperature get up in the 60s on Mars sometimes. The atmospheric pressure does change daily as to what's happening, and this is a pretty sensitive scale. So there's a daily variation, and then there's also a low pressure at night frost conform, carbon dioxide frost conform, and lower the atmospheric pressure. There's also a seasonal event when the southern pole forms its very thick carbon dioxide layers. That's pulling carbon dioxide out of the atmosphere of Mars and measurably lowers atmospheric pressure by about a factor of 2 on Mars. So it's a significant event. The Viking landing site, the average winds are about 15 miles an hour, and up to 60 in a dust storm that would come across. Mainly a carbon dioxide atmosphere, a little bit of nitrogen, a little bit of argon, very, very little oxygen, and little atmospheric water vapor. The carbon dioxide in the atmosphere can form clouds, and that's not uncommon to see above the volcanoes. There's a little view of the South Pole and the deposits that build up during the winter. Frost from the Viking lander photography. There can be fog in some of the craters, and then the winds create kind of waves in that fog. So why does Mars have a thin atmosphere? What's going on here? The atmosphere of Mars is about the same as the atmosphere of Earth at an altitude of 20 miles. So too thin to breathe, and it's carbon dioxide anyway. So why is it that Mars has such a thin atmosphere? Well, it is possible, and just some speculations, maybe asteroids, big impact, blew off part of the atmosphere. An impact could cause high temperature for a while in the atmosphere and cause a greater escape. And where Venus had a runaway greenhouse, Mars has a runaway refrigerator. Water vapor condenses on the rocks, and carbon dioxide goes into the rocks. That lowers the ability of greenhouse effect on Mars when the carbon dioxide gets taken out of the atmosphere. And that leads to more water vapor condensing on the rock, and that causes more carbon dioxide to get into the rock following that water vapor. Then we also have solar wind eroding the atmosphere. Since Mars does not have a global magnetic field, it has less protection for its atmosphere, and the solar wind particles can come in and collide with molecules in Mars' atmosphere. This is being studied now by the MAVEN spacecraft that just went into orbit in the fall of 2014. So atmosphere on Mars, very thin, but there is wind. There's a big temperature variation as to what occurs from day to night because we don't have the atmospheric blanket. Do you want to live on Mars? Now, if you're going to live there, you better plan ahead. So I want you to be thinking about what should be done about water, food, and oxygen for the people on Mars. What about the shelter that they would need? How would that be different than a home on the Earth? How would they do communication with the Earth? And then think about some costs too. To get something into low Earth orbit, about $9,000 per pound. The cost to take something to Mars, one estimate was $200,000 per pound. It's going to be an expensive trip to take a lot of food, a lot of water, a lot of oxygen, and so forth. So can any of those materials be, in a sense, harvested on Mars? Give that a little bit of thought. And then some, the Spirit rover here. If you see this little dot here, that's the Earth, seen in the morning sky from the rover on Mars. So you ought to be writing down some questions. This finishes our discussion on Mars. Write down some questions, and we'll try to give you a few more answers in class for my students.